Okay, we'll be discussing the practical first. The practical. Okay. So yesterday, you tried the practical I gave you? You have the set. So let's discuss today's class. Okay, I already post the one example on the times. Okay, I put it under, where is it? Where's practical? Yeah, design experiment 1. Okay, can see the document?
Yes.
Yes. Can, okay. So one example of setup, the one we discussed yesterday, this could be one. Okay. So this one example. So we have a pulley. We have mass A on top, mass B here. Yeah, we can allow the mass A to fall down. We have a bucket of sand as a safety. And we have 2 marker for H to find the time. But the H must be quite close. The H, there is a mistake. H have to be quite close to the mass. Okay, the H must be quite close to the mass, up to here. Okay, because we're taking initial velocity as 0. We have a G clamp, tight clamp. Yeah, this is one example. Okay, you can use another retort stand at the side if you want. Okay, as I said, sorry. Click this. Okay, ini at the side here, about the mass here, MA. You can have another retort stand if you want. You can have another retort stand. You can clamp with the, what do you call? You can clamp with the photo gate if you want. The photo gate, light gate. Let the mass pass through that photo gate, connected to a electronic timer. Okay. Here in the diagram also, one missing is the ruler. You can put a ruler at the side here, and you put a set square to check it's perfectly vertical to find the H. Also can be added. Okay. So how do you write it? Okay. So first, it's one example. So you can take a picture of this. I already post this in the Times, so you can view later. Okay. So first you write independent, dependent, variable to kept constant. The mass of MB to be varied. Dependent is acceleration of A. Variable to kept constant is mass of A. And then procedure. Procedure focus to how do you calculate the independent, dependent, how do you make the variable to kept constant. So measure the mass of body by using a top and balance. You say top and balance, you get mark. Measure the distance h shown in the diagram by using a ruler. Please add by using a ruler. Okay, put ruler. I couldn't write here. So please add measure the distance h in the diagram by using a ruler. Okay. Okay, maybe I can, sorry, maybe I can use this. Hold on. This is better. Okay. So here, draw So measure the distance by using a ruler. Okay. So measure the distance of the object A, travel distance by using a stopwatch, ticker time, or light gauge. How do you measure acceleration? So how do you measure acceleration? Find the time, introduce the formula. This could be a detail mark. This can go for a detail mark, T1 mark. H equals to half AT squared, U taken to be 0. Repeat the experiment for a different MB value. MA kept constant, mass of A kept constant, mass of B is changing. Okay, this is how the procedure you should write, but put it in point form. Please put it in point form. 1, 2, 3, 4, 5. You can start your reading with, you can start the procedure by writing it. Set up the apparatus as shown above. Okay. You always can start your first wording with this: set up the apparatus as shown above. Then you elaborate about the setup, measure the mass, and so on. So this carries 4 mark, including the diagram. Okay, diagram is 1 mark. Okay, any question? Just one example. Okay, one you can take a picture, but this document is in the Times law. Okay, scroll down. Any question from your procedure, guys? No, Okay, after procedure, write what? Write analysis. Under analysis, you must tell what versus what to be plotted. Graph of acceleration A versus 1 over B is plotted. You get 1 mark. The graph straight line with the negative intercept is obtained, and the gradient is negative G. You get 1 mark. Okay, then the equation is valid. Okay, it's a straight line with a negative intercept, straight line. Intercept is negative G. What is the gradient? You tell the gradient. Gradient is missing here. What is the equation in the gradient? Anyone? What is the gradient formula you get? Oh, gradient no WMA. What is the formula? Acceleration equals to WA over MB, is it? Minus G.
G.
Your gradient should be what? The gradient should be WA, right? Because you plot A versus 1 over MB. Okay. Y equals to mx plus c. So y is A, your x is 1 over MB. Okay, 1 over MB. So gradient should be WA. So here the missing is, you must say gradient is WA. That's another 1 mark. You must tell what versus what. You must tell gradient is what. You must tell intercept is what. Intercept is negative G. And you must tell what shape of the graph, straight line. And get 3 marks for analysis. Okay. Next. So precaution. Okay, what is the safety precaution? Anything with mass, you can say catch the falling mass by using a bucket of sand. Here there are 2 given, but marks only given 1, only 1 for safety. So extra detail mark, this is where you need to get detail marks is actually 6 detail mark. 1 you get for the safety, so another 5 detail, another 5 extra needed. So yeah, these some details. Oil the pulley to reduce the friction. Use the clamp to support the holder by the pulley. Increase the distance H. This is a very good point, third one. Increase the distance H. Use a bigger H so that the percentage uncertainty in the maturing of T can be reduced. Right? Big reading will give a smaller percentage uncertainty. Okay. Okay, next. Mass of body B should not be too much smaller than mass of body A. Acceleration might be too high. Yeah. The watch might not be able to measure the time T accurately. So don't use a very big mass, very big or very small MB. The acceleration might be too big or too small. So do a preliminary, experiment to check the most suitable MB, so that the acceleration is not big or small. You can add more. Make sure the ruler attaches perfectly vertical by using set square. Okay. So this is how the report should be done. So altogether, what? Problem 2 mark, method 4 mark, analysis 3 mark, detail will be 6 mark. This is the total you're going to get. So altogether 50. Okay, any questions, guys? This is one example. That's how the report should be. Okay, any questions?
Teacher, that means, teacher, when we are calculating grade the G, that means we calculate without the mass B, right?
Yeah, without mass B, just the gradient only, right?
So that means after we calculate G and then we calculate wait.
No. The y-intercept is your G, right?
Yeah.
So here you don't need to tell, you just tell y-intercept is negative G, that's it. You can't calculate G, right?
You can.
Because you don't have data, right?
No.
Data is not given, right? This experiment, data not given. You just ask to design only, that's it.
Okay.
Any other questions?
Also, when it says like weight of B and weight or mass of A and weight of B, does that mean that there is the weight and mass when it is attached with one another or when it is separated?
Supposed to be separated. Separated. Mass B separate, mass A separate. You calculate.
Oh, so that means why is mass B even attached if that's the case?
Mass B didn't attach. No. Yeah, you need to calculate. Are you asking me to find the mass B means together or separate? Is it?
No, like if I only need to weigh, for example, I need to know the mass of A and weigh the mass of B, and I only need G by free falling A, right?
But free falling A connected to B.
Or Y connected to B.
You see, MA is connected to B, right? By using this string.
So that means I calculate acceleration while it is also connecting to B.
Yeah, because this connecting system is the equation given, right?
Okay.
For this connecting system is the equation given for that acceleration.
Okay.
The A equals to omega A over mb for this system, for this connecting system.
Okay.
But when you calculate mass B, only mass B you detach first, calculate the mass B and calculate out. WA detach first, calculate the mass A times with G, you get the WA. Okay.
So that means we are actually calculating A or G actually.
Actually, we are calculating the question asking for what? The question asking for prove this equation.
Proving.
Proving this equation.
So that means we need to
so
prove by finding G.
You need to, how do you need to design an experiment. You tell this is you do, and this type of graph you plot, and if the graph is like this, then you say, and then this is valid.
Okay.
That's what you should do.
All right, I see.
But don't tell this is valid. Don't tell it this is valid. You say if the graph is like this, the gradient is like this, then this equation is valid.
So that means that we need to design experiment just to prove that that equation is valid for this experiment.
You are giving an idea to the science world that to prove this relation, this is how the experiment to be done.
Okay.
Okay. Okay, guys. So this is D1. Okay, now homework. Please do D3. Skip the D2 first. D3 is what? D3, yeah. Okay, set 3. Yes, D1. Skip the D2 first. Okay, D3, efficiency of motor. Okay, as a homework, we discussed by Friday lah. Do this D3 as a homework. Okay, D3 as homework, and for the other practical, right? Your C1, C2, C3. Okay, this one, I want you to try C4 as homework. Okay, C4, D3, these two going to be homework. We discuss on Friday. Okay. Okay, so now let's go back to the theory. Okay. So quantum physics, we are halfway. Okay, what we did so far? We learned about photon, we learned about photoelectric emission, we learned about how de Broglie contributed to the world about wave particle duality. Then we talk about how Niels Bohr introduced the energy level of an atom by using a quantum idea. Okay, so we done up to 12.4. We done up to 12.4. So today we just want to cover the 12.5. 12.5 band theory. Band theory. Okay, so let's go on. Okay. So this part is actually a fact to remember. No calculations. This one. Okay. So band theory. Band theory band theory is a theory line. It's in solid that outer electron energy levels become smeared out to form a band. You see, when every atom as an electron energy level, right? So as a electron energy level, when all the atoms are aligned together, the energy level it seems is form a region of crowded energy levels. Like for example, there is some crowded region where the electron can stay, some region where the electron can't stay. It's called band theory. And solid outer electrons energy levels become smeared out to form a bands. So like this. Okay. This is how the region. This is the energy levels. This is the energy levels. The bottom is the nucleus. Bottom here is the nucleus. Okay. So imagine the nucleus is at the bottom here. Okay. The electron is at the bottom here. Sorry, nucleus. Nucleus is here at the bottom. Okay. So they say, according to band theory, they said electron as energy levels at three bands. The lower band is the energy level called it's called valence band. Valence band. Like helium, right? Helium 42, right? 42. It got how many electron? It got 4 electron, right? So how many shell it has? First energy level and second energy level, right? 2 electron here, another 2 electron here, right? So these electrons are called valence electrons. Valence electrons, they are under valence band. They are in the valence band. Okay, electrons are under valence band. So electron under valence band are connected to the nucleus. Okay. Then after valence band, our Form 5 knowledge, only up to valence band. You know, our discussion, electron means only talk about valence band. After valence band, there is a region called forbidden gap. We call it as a forbidden gap. Forbidden gap. A gap where electron cannot stay at all. There is no gap. There is no electron can stay. Okay. Then after that forbidden gap, you have another band called conduction band. This conduction band. Here electron can stay. Okay. If electron can jump from valence band, getting photon energy, and he jump to conduction band means the electron can promote current flow. Electron can promote current flow. If it's electron, if it's under conduction band. Okay. So every material have these three bands: valence band, forbidden gap, conduction band, according to band theory. According to band theory. Valence band, the electron trapped to the nucleus, not free to move. They cannot move from one atom to another atom. Okay. But electron in conduction band, they can move from one atom to another atom. They are freely move around in the metal. Okay, contribute to the current. Forbidden gap, a region where no energy levels for the electron to stay. Okay, so this is band theory. Yeah. Okay, now the thing, you see this picture here. How big is the forbidden gap is the one differs between insulator, semiconductor, and conductor. Okay, the forbidden gap. The insulator, it seems found to be as a huge forbidden gap. It means impossible for the electron to jump to the conduction band. Okay, never promote electric current flow. Semiconductor, the forbidden gap is quite small. You give a little energy, the electron can go to the conduction band, can promote current flow. Conductors, it seems the valence band and conduction band, it seems overlapping. So the electron can stay in the valence band, can move in the conduction band. So electron stays in the conduction band and also valence band. So anytime you apply a voltage, it can promote current flow. This is how the bands are located.
So that means that this is the same as in diode.
Okay, same as what?
In diode.
Diode is semiconductor, right?
Like the gap between them, that means that the electron needs a specific energy over that energy so that it can go to the conductor.
Yeah, correct. Because diode need about 0.7 volt to initiate the current, right? Yes. Something like that. So because there's a small forbidden gap, so you need to overcome. So you need some energy first to jump to the conduction band. Okay. Okay. So band theory about insulator, the one I told you just now, there is a big forbidden gap between the valence band and the conduction band. No electron occupies in the conduction band. The voltage of cell insufficient to lift the most energetic electron. So the electron not free to move through the material. So such as plastic paper, you know that lah, the insulator. Last time Form 5, we know insulator never conduct electricity. Why never conduct electricity? You say no free electron. But now under conduction band, they say why you can't have free electron? You need to answer it according to band theory. You need to say there is a big forbidden gap. Okay, electron from valence band unable to jump to the conduction band because the forbidden gap is huge. So that's the reason, Lana. This is the reason you have to tell. According to band theory, they will ask you to explain why, according to band theory, paper, plastic never conduct electricity. Then this is the story you have to tell. You say insulator has a huge forbidden gap. So electron occupies only, no electron occupies in the conduction band. So lots of most energetic electron, not even most energetic electron can jump to a conduction band. So no current flow. Okay, a fact to memorize. Okay, next. conductor, band theory. There is an overlap between the valence and conduction band. Hence, the electrons are free to move about. The conduction band is partially filled with causes the metal is conductivity. The potential difference applied across the conductor, electron gain energy and move through the metal causes current. Yeah, so that is conductor. Okay. Third, the special case is the semiconductor, a little long theory. Yeah? Semiconductor, the small forbidden gap between the two bands, the valence band is full, the conduction band is empty, still empty. But if you give energy in terms of thermal excitation, you give heat. You give little heat to the semiconductor, electron gain energy, you jump to the conduction band. From the valence conduction band, thermal causes more electron have enough energy to jump into the conduction band and increases the charge density, therefore increases the current. Very important, charge density increases. Okay, what is the current formula you learn in your AS in terms of charge density? You have to recall back. What's the current formula? Hold on. What is the current formula you learn? I equals to N A E V, right? VD, right?
Yes.
This is the current formula. Okay. For semiconductor, they'll ask semiconductor, for example, you know, semiconductor like LDR, thermistor. Okay, thermistor. Thermistor. Thermistor, when temperature rise, what happened to the resistance? Anyone still remember?
Decreases.
Decreases. Current increases.
Yes.
Thermistor is a semiconductor. Okay. So why thermistor, when temperature rise, resistance decrease, current increase? So you can explain in terms of band theory now. Okay. So thermistor as a semiconductor, when temperature rise, what happened? When the temperature rise, electron gain energy, thermal excitation happens, electron gain energy, more electron go to the conduction band. So what happened? The charge density increases, promotes more current. Therefore, resistance decreases. So the band theory explains why this happens. Last time, no, right? Temperature increase, resistance decrease. Something to remember, right? But now, why this happens? When temperature increase, electron gain energy. So the electron from valence band jump to the conduction band. So more electron contribute to the current flow. Charge density increases, therefore current increases. So charge density therefore increases the current. Resistance of the thermistor start to decrease. Okay, something reasoning. What you learned last time. Okay. You know LDR, light increases. What happened to the resistance? Anyone? Light increases, resistance decreases. Okay, now can you explain by using this band theory? LDR also is a type of semiconductor. So the same story. So when light is exposed to the semiconductor LDR, the electron gain energy from the photon. Then what happened? The electron
Jump.
to the conduction. Then what happened? The charge density rises, therefore promotes more current.
Yes.
The band theory explains now, give reasoning why that happens. Okay. Okay, now band theory. Okay. Now this is one question. When a conductor is heated, the resistance increases. But when thermistor, semiconductor heated, resistance decreases. Why? We know why thermistor When temperature rises, the resistance decreases. Because of what? The story lah, right? The charge density goes up. But why in conductor, when heated, why resistance increases? Because of this reason. When a conductor is heated, its resistance increases because the atom vibrates more. The atom start to vibrate more. The electron find it more difficult to move through the conductor. Therefore, the drift velocity decreases. But in semiconductor, the resistance decreases with an increase in temperature. Electron can be excited to the conduction band. Conductivity increases. This is for semiconductor. I tell you the truth, you see, I equals to NaEVd, right? Okay. For conductor, for the case of conductor, N doesn't change. The charge density of conductor doesn't change because all electron can be in the conduction band. So charge density, you increase temperature, charge density never change for conductor. Conductor charge density is fixed. Okay, because all electron can be in the valence band at the same time can be in the conduction band. So charge density doesn't change with current, with temperature for conductor. So to conductor, when the temperature rise, atom vibrates more severely, drift velocity decreases because electron cannot move forward because atom oscillating. The atom lattice is oscillating, so electron got problem to move forward. Drift velocity decreases, so current decreases, so resistance increases for conductor. But for semiconductor, is what I wrote down. Write down. Semiconductor I equals to NaEVd. For semiconductor, when the temperature rise, the atom still vibrates. Of course, the same effect as the conductor happens. The atom vibrates. The atom lattice vibrates. So electron also face difficulty to move forward. So actually, for semiconductor also, the drift velocity is dropping. Okay, same as conductor, but because charge density is rising, the increase in charge density outweigh the decrease in drift velocity. Okay, the increase in charge density outweigh the decrease in drift velocity. Therefore, current still increases and resistance decreases. You got the idea? Good idea. But I tell you, in your exam question, when they ask you to explain why semiconductor, when temperature applied, resistance goes down, they never really tell about the drift velocity decrease. They never tell that normally in the mark scheme. They just give the positive side. They just tell semiconductor, temperature applies, charge density rises, current rises. They never really tell about the drift velocity decreasing. Okay. You want to mention, you can mention. You say charge density rises, drift velocity decreases, but finally you must tell this, the increase in charge density outweighs the decrease in drift velocity, therefore current rises. That's the actual story. But I tell you, normal mark scheme and the A levels, what they put, the temperature rises, charge density of the semiconductor rises. They never tell about drift velocity. Charge density rises, therefore current rises, resistance decreases. Full stop. For semiconductor. When it comes to conductor, they ask why heating resistance goes up. Here they tell that when heated, atom lattice vibration increases. So electron face difficulty to move forward. So drift velocity decreases, current decreases, resistance increases. So in conductor, about charge density, they never tell it. Charge density no need tell is fine because conductor charge density is constant. Yes, any questions here? So this is band theory. That's all about band theory. Okay. So what do you learn about band theory? So it's just it's a fact to remember. It's a new theory explaining why semiconductor conducts current at a certain time only, why conductor always conduct current, why insulator no way going to conduct current. all because of the forbidden gap. Okay, so this stories, this explanation you have to tell in exam. They can link to LDR, they can link to thermistor. LDR thermistor is a type of semiconductor. Okay, any questions? No questions.
Teacher,
Yeah.
for the semiconductor, does that mean that when the charge density increase, it outweighs the what's it called resistance?
It outweighs the decrease in the drift velocity.
Increase in drift velocity. Is that because the gap makes it so that the electrons jump towards the other towards the conductor instead of staying at one place?
No. Once the electron jump to the conduction band, electron need to move forward, right?
Yes.
But the electron face problem to move forward because the atom itself vibrating.
Yes.
The atom is vibrating, the atoms all vibrating, the electron cannot move forward. It moving forward, but with a smaller drift velocity. Okay,
So
drift
that means
velocity apparently decreases, but the charge density increases.
also that means that there is a sufficient amount of electrons, the charge density, that it is enough so to increase the current.
Yeah,
Okay.
that's what you have said. The increase in charge density outweighs the decrease in the drift velocity. The increase in charge density outweighs the decrease in drift velocity, therefore current increases. But as I tell you, you check the mark scheme. Mark scheme never not even talk about the drift velocity decrease. They just focus to the charge density only. Okay, so in the mark scheme, your Cambridge mark scheme, they just focus to the charge density. So what is it? In semiconductor, no need to talk about drift velocity also can lah. No need to talk about drift velocity. Just say when the energy absorbed, the electron jumps to the conduction band, charge density rises. Therefore, current in the semiconductor rises, resistance decreases. Full stop. No need to tell about drift velocity. If you confuse, how to explain. Okay.
Okay.
But when it comes to conductor, you talk about the drift velocity lah. Conductor, NAE, charge density of conductor never change, but because atoms vibrates more severely, electron has faced difficulty to move forward, so drift velocity decreases, current decreases, resistance increases. Okay. Okay, any questions? No questions, huh? Do you have class after this? Yes? Do you have class after this? 3 to 4.
No.
Oh, okay, sorry about today. So today I thought it's 3 to 4. That's why I put my phone charger. That's why I didn't see your message. Yeah. Okay, so okay, fine. I think I cannot do the next one. Next one is quite long. I need about 1 hour. The next thing we're going to do, still quantum physics. Quantum physics is one of the longest topic. Okay, in A2. So next one we're going to do is about, you go back to your A2 notes, quantum physics. You got quantum physics 3 PowerPoints actually. The quantum physics part 2. We're done with the part 1. That's the longest one. Next is part 2. We're going to discuss about quantum physics. About what? About X-ray. X-ray. Okay. X-ray was explained by using quantum idea. Okay. The quantum idea is the one explaining the X-ray formation. So you know what is X-ray lah? This is another medical device, medical what do you call, imaging technique we're going to learn tomorrow. Okay, so it's also another facts. We go through that. You can read through yourself first. Okay, we can discuss tomorrow. Any questions? No questions,
I have a question regarding the photoelectric emission. Teacher.
Yeah. What's the question?
Oh, when the frequency of the EM radiation increase, right, will the current will said to be decreased, right?
Current said to be decreased. Yeah, it's a little controversial. That's that. Some books say it's increasing. Okay, so what's your question? You tell me your question first.
But when the EM radiation increases in frequency, right, the energy will increase. Then doesn't this will increase the kinetic energy of the electron? And then since the current is dependent to the drift velocity of the electron, doesn't this will cause the increase in current?
Yeah, the kinetic energy contribute to the current flow.
Yeah.
Okay, this part still controversial because of what? Some books I've come across some books. Sorry, where's the? Okay, I use this. Okay, some books explain based on the power. The intensity. I told you, power over area. So energy over area time. So energy is what? NHF over area time. So intensity, and this intensity. So they say the N over T is greater. They say the photocurrent is greater. Based on this, they're explaining it. Okay. So based on this idea, if frequency is raised, if frequency is raised, N over T going to drop. So current should drop. Correct? According to this idea. But some book says frequency raised, N over T, of course, dropping, but they said current is rising. Current is rising, but they never tell the reason. Of course, it's linked to kinetic energy. Kinetic energy also rises, right? So greater the kinetic energy, you say current is rate of flow of charge. So you say more charge will flow in a second. Okay, so more current. I'm still looking for this idea, but I couldn't find any books explaining this. But in your Cambridge, right? In your Cambridge so far, in your A levels, they play safe. They play safe means what? They never ask about current. They won't ask about current. They'll ask about what? They ask about the N over T. How many particles we release per second? They will ask about this. Okay. But in STPM, in the other boards, they do ask questions about current. What will happen when frequency rises? And when the frequency rises, what happened to the current? In their explanation, they say N over T, the current is proportional to N over T. So when frequency rises, N over T drops. So current drops. That's the answer they say. Okay. So still controversial. Shike, let me look into this. Maybe in the next class I try to explain to you. Okay, but for sake of A levels, they will ask about the particle. How many particles released per second? This is what they're going to ask. The current, so far they never asked. But other boards explaining current in terms of N over T. They follow this formula. They say greater the frequency, smaller the N over T, smaller the current. Guys, can you hear me?
Oh, yes.
Can, So Shike, so the current is a very controversial part. I'm still looking for the answer. The EK affects the current, but I couldn't see any books explaining that. So A levels, as I said, they just go for the number of particles. Okay.
Okay.
But good question. Okay, good question. If you have any idea, you just share with me. Let's see. So, okay, guys. So I stop here. So I see you tomorrow. We will continue with the X-rays. Bye.